Hello, lovely people.
Yeah, today we'll be installing this front subwoofer.
And I am gonna help.
And you're gonna help, thank you. So today we'll be installing this manifold that I'm not showing the top on purpose. If you want to see what's happening on the top side of this manifold, you have to find the video on my Patreon, because for public this is sealed. For my Patreons, this is IB. So if you watched the previous video, you saw how I made this manifold. I made mounting points. I run the speaker wire just there, and now I'm gonna glue it in. So I will be using this no more nails construction adhesive. I did use it before in the insignia as well. So what I'm gonna do is just gonna run a bead all the way around there, and if there's gonna be any gaps, I'm just literally with a finger gonna fill in the gaps, and then I'm gonna bolt it on, and I'm very confident that it's gonna be sturdy as hell. So let me do that and let me show you how it looks like afterwards. Okay, so I did use the whole tube. I went all the way around. This glue, it doesn't set very fast. It needs like a full day to cure, so it's totally fine. And I do have a bead over there, and it's gonna be like Oreo. You just squash it in, everything is gonna come out, just even out. You can see something a little bit black over there. And the main thing, I put quite a lot on the top because I need the very top. There's a big gap to fill it in. If there's gonna be any other massive gaps, I'm just gonna use something else to fill in. So now I'm gonna try to put this in. So it went better than expected. Everything is bolted down. You can see I have a squeeze out on all the sides and inside as well. It's just at the very top I do have a little bit of a gap where I showed you in the very beginning. So there, I think I'm gonna use some spray foam, especially like here in the corner. Is gonna act as a little bit of sound absorber and decoupler as well. Maybe put like here as well, so I can make it literally flat with the floor. Just let the foam to expand and then cut it, make it flat with the foam. Here as well, the whole corner, fill in and just cut it and make it like, I don't know, a little bit nicer. And I'm gonna do exactly the same on the top. But yeah, the wire's in. If you're wondering why one is longer than the other one, because I'm gonna wire the stereo integrity BM-11 in series, so I need one wire to be extended, and this is gonna go into the back. But yeah, now I'm just gonna have to wait until the glue is gonna dry. What's the curing time on this one? Adjustability time 5 minutes. Will hold something after 12 hours, and fully dry 24-48 hours. So yeah, I think I'm gonna leave it for a full day or two. I'm gonna order the spray foam, and when it's gonna be dry, then I'm gonna do the spray foam, and I'm gonna show you how it looks like afterwards. But in this video, we will measure it. I'm gonna take the impedance graph, we're gonna take the RTA, and we'll see how it performs here. But you can see the thickness wise, even with the grill, I'm not losing absolutely any space. The carpet can go back as it was, and I think it's gonna look factory. So now I'm gonna go to Amazon and order some spray foam. This is 3 days later. It is evening. I just came back from work, put the little one to bed, read a book and everything, so now I can do my stuff. What I want to do today is I want to do the spray foam, because tomorrow when the spray foam is gonna be expanded and everything, I can cut it and I will be able to fit the actual subwoofer and start measuring. So today I want to do this. At the same time, I removed the mids as well, because you can see I have a few gaps here. I want to use the same bottle, because that's the thing with this spray foam. Every time you use it, if you leave it for half a day, that's it, you can bin it. So I want to use as much as possible. As I mentioned, I'm going to go all the way around all of these corners as well, and I'm going to put some here in the vents. I removed the vent, so I'm going to put some here, some there, in that corner over there, and a little bit here, and then I will be able to either put the same material just like a sticker, or use some black spray paint so it would be like not again, because now it's just literally a gap. I would like to do that on camera, but I don't know how it's gonna go, so I'm gonna do it off camera. I did make a little bit of a mess, but it's just one splop there. It's fine. This, I don't think it's gonna expand anymore, so I'm just gonna cut it flush with the dash, this a little bit spray paint, so it would look black and we're not gonna see it. Same side on that side, and here is gonna be perfectly fine. So now it's getting dark. I'm gonna leave it to dry out overnight. Wear gloves, people. Oh, man, I'm so stupid. I need to wear gloves, but that's the thing. I'm tired. I want to do it as fast as possible, and I just want to go to sleep. And now, yeah. Okay, I'll see you tomorrow, guys. Good morning. This is the next morning. I just woke up. Come to inspect everything. Everything is solid. Nice. So, now, breakfast time. Little girl goes to school. Shut up, you there. And after that, I'm going to trim it a bit, make it look a little bit nicer, and I'm going to show you how it ends up. The best tool to do with foam is serrated bread knife. Just don't tell your wife that you use it. I'm lucky enough because my wife doesn't watch any of my videos, so I'm gonna be fine. I did cleaned up a little bit. Now, I know it looks a little bit ugly, and it's totally fine, because what I want to do now is I want to put the sub in as fast as possible, because I know I will have rain in the afternoon. I'm going to talk about the mid a little bit later in the next video when we're going to measure them as well. This video focuses the front subwoofer. What I want to do is I want to take the impedance graph on free air subwoofer when I put it in, and I want to try to fix a few rattles, because I know this one, I think this one is rattling quite a lot. It was rattling from even the Atoto when I had it there. This was rattling. If you remember, when I pushed it, it stopped rattling. When I let go, it does. So it's, yeah, it's these connectors. So I want to treat a few major rattles, and then we can measure and see what we have. Okay, let's do an impedance sweep. So I did remove all the stickers. The pole vent is open. I'm just gonna do like this. Impedance start. Let's have a look what we have. Yep. So I did wire it up to 4 ohms because the amplifier that I'm going to be running is going to be stable only up to 4 ohms. There we go. Maybe, I'm not sure which amplifier I'm going to use, but I might be able to drop the coils in series down to 1, and we'll see. Okay, so we have 35.2, and we don't have any major nothing in the impedance graph. Let me put the subwoofer in the manifold and let's measure again. The sub is going in. I just want to show you the tightness. So these screws are fine. That one on the top, you can see I need to use this little thingy because it's so tight, but there is plenty of space. So let me tighten it up, and then we're gonna measure impedance again. Okay, the sub is in. Now it's gonna be the moment of truth. I'm gonna do this live. No idea what to expect, so we're gonna find out together. Start. I'm a bit scared. Let's have a look. Bam, all impedance. Nice! So with the new one, which is this one, the FS dropped to 33. So the FS is dropping because the manifold holds the sub, so it's a bit more stiff compared to free air when it a little bit vibrates. So that's fine. What, yeah, we're looking at this. The impedance is the same. If I'm going to remove this, see, we do have a little blip. If I'm going to zoom in a little bit, and like that. There we go. So we do have a few blips. One blip is at 145. The other one is here at 257. But maybe this one is here as well at 85, a little blip. But we don't see any like major peaks. So that I'm happy about this as well. Now these potentially could translate into some discrepancies in the frequency response, so we're going to have a look at that as well. I'm not too worried about this one, which is 250. It's way too high. I'm not even worried about this 147 because it isn't the crossover region. It's going to be because I'm going to be crossing at probably like 120 something. I'm a little bit concerned about this. It is a little wibbly wobbly thing, but we know that with impedance, even a little wobble can translate into something not good. But in general, overall, yeah, this one, it doesn't have absolutely anything. I'm happy. So now first I'm gonna see if we have any rattles anywhere. Okay, so dummy me. I don't know if you can hear, there is a little bit of air hissing going through. And dummy me is like, what the hell, maybe I have a hole or something. But I forgot that I have these 4 screw holes for the grill. So that's why probably the impedance graph was wrong as well. And now I do have hissing. So let me put the grill on and let's see again. But to be honest, like this one, it doesn't rattle. So I think the rattling that we heard with our Toto probably was the actual Toto sub itself, or maybe a metal part was touching something, but this doesn't rattle at all. So let me put the grill on and let's see again. Cool. There's no hissing. Yeah, there's no hissing, nothing is rattling in the kick, which is great to hear. There's no air leaks or anything. What I used to have is a little bit rattle there because this is not fixed properly because I'm still planning to do the roof and everything. So this panel was rattling. Now the problem that I'm having now is that this is on max volume. There is something a little bit rattly somewhere, but not in there, somewhere around here. Maybe it's these speakers. So I have it crossed. No high pass, low pass at 200, just to see because I don't want to get copyright for the music that I'm playing. And I'm missing volume. I'm missing volume because now, oh man, it's so hot. I'm running it on a 4-channel bridge, 2-channel, so it's getting maybe a couple of 100 watts, but it will need much more power. And probably then, when I'm going to have more power, more excursion, probably then we will find some rattles somewhere. But for now, I'm really happy. I'm gonna go back to the Focusrite. I'm gonna redo the impedance because we will see if there's a difference when we plug those 4 holes for the grill, and then we can start measuring the frequency response. Okay, impedance, grill off. So let's remove this one. This was without the grill. Okay, let's do this again just to see. Weep. Is there gonna be any difference? Okay, no, not really. So you can see the level is different. Probably I just literally touched a little bit of the gain knobs. That's what happens with this Focusrite all the time. But this is the same. The new one is the purple one. This is so it's kind of the same. There's absolutely no. Actually, this one here area, you can see this is a bump, and here we don't have that bump. Maybe that one, not sure. Okay, let's start measuring with a microphone. Took the first measurement. I'm going to show you that what I want to test is I want to test it as it is like this, then I want to put the carpet on top and then the floor mat as well and see if that changes anything, because I want to know, do I need to cut the carpet and leave it totally open, or I can cover it and leave it stealth and literally invisible. Okay, so this is the first response when the subwoofer, everything is open, the carpet is not there. When I put the carpet on, just like this, we do have this. I do have a 10 dB scale just for us to see a little bit better. So when you put the carpet on, everything like above 600 here gets attenuated. This is a cone breakup. This response is full range. The amplifier that I have is totally full range, 2020. That's why we have the response all the way up here. So the carpet removes this, and it does remove all the high frequency content as well. There is a slight reduction in bass as well. You can see here I'm losing maybe like 1 or 2 dB. Now when you put the mat, the rubber mat on, we have this. So from the carpet and mat, there is no difference in the bass, but here you can see above like 125. For some reason, with the mat, we have an increase in level, but then above 600, a massive reduction, and you can hear it straight away. So this rubber mat is acting as an MLV, mass loaded vinyl, and mass loaded vinyl, as you know, helps with noise and everything. So even just a rubber mat will help you with road noise and everything, and you can see it's a reduction of 10 dB in higher frequencies. So if we're comparing carpet plus mat versus when it's totally open, the biggest difference is here at the higher frequencies where it doesn't matter for us at all. And we do have a reduction in bass. Let's zoom in just to see how much. There we go. This is a 2 dB scale. So let me do this one. Let's take measurement 3. And let's increase, there we go, kind of the same, 1 dB. There we go. So there's 1 dB loss of energy when you put the mat and the carpet on top. So for me, it doesn't matter. Like that 1 dB, it doesn't mean literally anything. And the response itself is, I don't know. This is compared with what we had previously. This is again on 5 dB scale. This is in a small enclosure, 0.3 cubic foot. This is when I did the initial test with the test enclosure. If you remember, all the subwoofers went into the same enclosure. So if we're comparing this with the current one, IB, we do have a massive reduction in this peak. This peak is because of the high Q in a small enclosure, and it was sent at about 70 hertz. The high frequency extension, we do have much more high frequency because the enclosure was much more forward, whereas now I have it pushed right next to the firewall. That's why we do have a better extension in the high frequencies as well. With the enclosure as well, we had this massive cancellation at 300, not sure why, but the main difference is that we don't have this peak and we have a much linear response. If I'm gonna overlay the target that I wanted, let's have a look. So this was with the enclosure, if you remember, and I said that in order to match the target, I need to remove this massive peak of 10 dB and leave everything as it is. Now, with this application that I have now, it's kind of weird because I'm just going to reduce this a little bit lower. We absolutely don't have that peak. And it looks like it got worse, but in reality, it got much better. If I'm going to go to the EQ window right here, we're going to apply the same target that we want, and I'm going to apply crossovers. High pass at 25 hertz and low pass at 95 hertz. And this is our predicted response. So I'm going to remove the original one. This is my response matching to the target only with crossovers. Absolutely no EQ, and you can see like from about 35 it matches literally perfect all the way up to 150 with absolutely no EQ. So in one way it might look that it's a bit worse because we don't have that peak that we had that kind of helped us to gain extra energy where the target needs. But in reality, I would have needed to cut that peak anyway. And now I don't have to cut absolutely anything. I just need crossovers, high pass, low pass, and that's it. And I think for me, this is much better. What I want to show you next is the modeling, why I decided to go with this application, how I did it, and we will check if this response that we got matches the modeling. So for this one, you need a software called Vitrix CAD, which is this one. If you download it, go to Tools and you go to Enclosure, it'll give you this. Here we have some subwoofers. You can enter your own. I did have a separate video about this probably like more than a year ago, but nobody watched it. So now you can watch it again. You need this software because this one allows modeling in infinite baffle. So what you do is you take the closed enclosure of a volume that we need. So in this case, it's 10-liter volume. And we apply some power here, 400, 500. Okay, so 500 watts of power. And we see here, this is our SPL graph. This is power and excursion. So mainly we're looking at excursion. And if you remember, it was exactly the same with WinISD, that we're like halfway with the excursion. We have plenty excursion at 500 watts. And this is our SPL graph. What you can do with this program, you can export SPL as TXT file. And then you can literally drag and drop it into REW. This is the same frequency response that we have here modeled. And then we can go to infinite baffle and we can model how the same subwoofer behaves in infinite baffle. So with an infinite baffle with 500 watts of power, we can see we have this SPL graph and we have this excursion where it goes over Xmax below 40 hertz. So in infinite baffle, we need to add a high pass of 25 hertz, somewhere 20-25 hertz, and then we can see the excursion like 1 millimeter above Xmax at 30 hertz, which is perfect. And with this modeling, we export this SPL graph into TXT. import it into REW, and we have this. So this is a difference in modeled response between this stair integrity driver in an enclosure, 10 liter, 0.3 cubic foot, and in infinite baffle. And we see there is a huge difference where we're losing this peak and we're gaining a little bit of this bottom end. So now what we can do is, if we have a frequency response such as this in an enclosure, we can model how this subwoofer would behave in infinite baffle before installing it. So this is exactly what I did before making it IB. So you do this by going to actions and you do trace arithmetic. With trace arithmetic, we are choosing on A, we're choosing the actual frequency response that we measured in the car, which is number 5, this one. And then in B, we're choosing the modeled response in a box, which is number 8, this one. And then we choose A divided by B. So we take one divided by the other one, we generate, and this curve that is generated, which is this one, A over B, this is what is called our transfer function. Basically, this is how the cabin location affects and changes the frequency response of any driver. So we can see that this is kind of the same, and then we have a massive boost here. And now what we do, it might sound complicated, but bear with me. I'm taking this that I got, A over B, this transfer function, and then I'm gonna take the modeled response in infinite baffle, which is this one, with the 25 hertz high pass, which is number 7. And then what I'm gonna do times A times B, and I'm gonna generate the curve again. And this is the response, predicted model response in infinite baffle compared to a sealed enclosure. And you can do with literally any sub you want. For example, in this, you take any subwoofer that you want. You can put an 8-inch, a 6.5-inch, whichever you want. You model it in infinite baffle, export the SPL, and do exactly the same arithmetic, and you can see how a different subwoofer will behave. So now the question is how this is the modeled predicted response, matches with the actual response that we measured. So the actual response that we measured is this. And you can see that it doesn't really match. It doesn't match because of two factors. First one is that this original graph that was measured with a monoblock that had a 200 hertz low pass, so it wasn't full range. And the second thing is that the location is not exactly the same. Now with this one that I measured recently, it is probably like 20 or 30 centimeters deeper into the footwell, so it is very, very different locations. However, we do have this dip here, this is a bit lower, and like in general, if you would have exactly the same location, you would have the model response matching very, very good compared to the actual response that you measured. Now, if I would have that subwoofer in exactly the same location, exactly the same box, however, I would vent that box in IB, I would get this modeled response, I guarantee, because I did this experiment before and it did match extremely, extremely well. In this case, it doesn't match because the location is not the same. But this is how you do it. I do have, again, another video, but in general, this is my response. With no EQ, with no crossovers, it plays, yeah, all the way down to 10 hertz and plays all the way up to 160 or so, which is extremely good for integration into literally anything that I want. And to be honest, like with this, I can choose any target I want. I can cross it much higher than I want, like 120, because this one, if I'm gonna remove this one, you can see it matches perfectly well, so I can cross it much higher. And to be honest, I could cross it a bit lower, but there is no need for it because even in this simulation that you saw, without 25 hertz high pass, it will go over Xmax. So yeah, I'm not gonna cross it lower, but I do have some flexibility in crossing it a little bit higher if I want to. I think I can potentially cross it. No, I'm not gonna cross it into the dash speakers. The dash is not gonna play that low. Well, to be honest, let's try this. Let's do 200, see what happens. 200. Yeah, with some boost, with some EQ manipulation, I could potentially 220. Yeah, I could cross it into the mid-range into the on the dash in the 4 inches. I think it would be fine just with EQ, just remove this peak. This is gonna match quite nice. So yeah, potentially I don't need any mid-bass drivers in the kicks or in the doors, but we'll see how it's gonna go. Anyway, in general, I'm super happy how it ended up. I have a totally flat response that I need only high pass and low pass and no EQ work at all. So the results are probably even better than I expected. I'm super happy about it. Okay, my last thoughts. With the leg space, yeah, you can put your feet there. It does protrude a little bit. You can see here, yes. So I was mistaken that I thought it was going to be totally flat. It does protrude a little bit, but like if you wouldn't know that there's a subwoofer, you wouldn't be able to tell. Now the only thing, like here, there's a little bit of a scoop out. So I might put something under the carpet to make it pop up a little bit and to make it a bit nicer transition. But I don't know if it's needed, to be honest. When I had the enclosure in without the grill, I had a passenger and I asked him, does he feel anything? And he said that, yeah, like if I'm gonna put my feet like this, I can feel a little bit, but like normally driving, you don't feel anything. So I'm super, super stoked how everything ended up. To be honest, it's much simpler. This install is much simpler than having a box made out of fiberglass and all messy stuff and everything. I will keep it stealth. I'm not gonna cut the carpet or mat or anything because I'm losing literally just 1 dB. That 1 dB, it's nothing. So I will keep it totally stealth. I need more power to that subwoofer. 300 watts that I have now, I don't think is gonna be enough. I will put probably US amps. I'm gonna wire this subwoofer down to 1 ohm, and US amps, I think it does like 450, close to 500 watts per channel into 1 ohm load on music. That's gonna be perfectly fine. Yeah, I'm happy with all this stuff. How it looks like, I don't think I'm gonna do anything. Like, I tried to make it look nice, but like, why? To be honest, I didn't know if I'm gonna keep it open or closed, but all this black hardware, black paint is pointless. Even like this foam, I'm gonna keep it as it is because I'm not gonna see it, nobody's gonna see it, and it's just not worth any kind of time investment or anything. In regards to the mid bass, I'm not sure if I'm gonna put the mid bass. If I will, I might keep the doors, because if I will need the mid bass, just literally cover the gap from this, which can play up to literally 200, and this that can play down to 250. I don't know, we will see. I think it's going to be a very interesting experiment when I'm going to try to blend this front sub and these 4-inch mid-ranges. We will see, but for now I'm going to keep it as it is. I'm gonna tune it, play it, and enjoy it. And again, as I mentioned in the previous video, don't do what I do. This is an extreme case for an extreme install for a very specific purpose. You don't need to do that. 99% of the people would be totally happy with a 6.5 inch or an 8 inch in small 0.3 cubic feet enclosure. You don't have to have an 11-inch driver and infinite baffle in your front footwell. But on the other hand, YOLO, you live only once. I wanted to do this in the Insignia, I couldn't, it broke down. And now when I have this build, I'm not gonna waste any time. This is done. Front subwoofer is fully functional, it just needs tuning, and it will need more power when I'm gonna redo everything in the back. It's been a long video, I appreciate it. Thank you very much for watching, guys, and I will see you in the next one.